Okay, I'm going to do another example of repeated, finding a fraction of repeated, of a decimal that's in a repeating form or non-terminating. So here's another example. There's the one that we did in class, 0.34, that repeats forever. Let's take a look at another one. This one's 0.7, repeats forever. And then the question is there a fraction that equals 0.7777 going on forever in a repeating, non-terminating way? So the question is, are we looking for a fraction? So in class, we showed you a number trick or an algebra trick. And so what we start with is we say, let x equal 0.7 forever. And then if that's the case, that's just an equation that's true. We let any variable equal a number. We then, if x equals 0.7 forever, 10x equals 7.7 forever. Because if I multiply, if we do 10 times 0.7 forever, what happens is you end up moving the decimal over one place, and so you end up with that. And so that's just kind of a number trick. And then with that kind of trick there, what we do is we do a little algebra and say, okay, let's do, so when then says, what's 10x minus x? You say 9x. And then using equivalent representations here, 10x is equal to 7.7 forever, and then x is 0.7 forever. And so when we subtract those two, 7.7 forever and 0.7 forever, what happens is you just end up with 7. So we can end up saying 9x equals 7. And so the fraction, we solve for x, and you get x equals 7 over 9. So then we end up answering that question, which is 0.7 forever is going to be equal to 7 over 9. And so then we have, there we go, we have that relationship there right here, equals 7 over 9. So if you get your calculator and want to verify that, you could take 7 over 9 and you end up with 0.7 forever. So you have 7 over 9 equals 0.7 forever. Okay, so let's finish with the second example here. This one's a little bit harder example. It's asking this question here of 0.911 forever. And so kind of looking at that there, this was a little bit more challenging problem, because in this trick we're trying to decide what do we multiply by, and what we're looking for is to multiply by how many times do we need to move the decimal so that we isolate, so we can get the repeating part by itself. So that's what we're looking at right there. And so in this case, we need to move the decimal one time to get us to this 0.11 forever. So let me show you what we do. So we would start in the same way. X is equal to 0.9111 forever. And if I multiply by 10x, let's see what happens. We move the decimal once and you get 9.111 forever. Now if I do a 10x minus x right here, what happens is the decimal parts are not the same. And so the trick here is to actually multiply x by 100x. And so if we do that, notice what happens. You get let's do that. You get 91.111 forever. And so now notice the key thing here is that these decimal parts, when I multiply by these two here, 10x and 100x, what happens is you have the decimal repeating part are now equivalent or the same, so we can now subtract them. So now we can go ahead and do that number trick, or the algebra trick. I can say 100x minus 10x. And again, we're doing this trick essentially again so that we can find a representation for a non-repeating decimal. So you get 90x. And then if you go ahead and we do the equivalent, 100x is 91.111 forever, minus 10x, which is 9.111 forever. When you subtract, this disappears. Do 91 minus 9. I think that is equal to 91 minus 10 is 81. Minus 9 is 81. 82. So when you solve for x here, you get x equals 82 over 90, and that would simplify 41 over 45. So if you get a calculator out and you go 41, way over there, go 41 over 45, you will see that that is equal to 0.9111 forever. And there you go.